This video always has the potential to get long, so I'm really sad to say that you guys won't get a joke from me in this video. I know, I can just hear your groans through the computer. We're going to be working on point-slope form, which is a new thing that's very similar to slope-intercept form, but a little bit different. So when we're looking at our y equals mx plus b, which is what we've been doing for, feels like forever, we have to ask ourselves, what do we need? Well, we need an m, which means we need 2 points to find our m. And then we need our b, meaning one of the ordered pairs has to have a 0 in the front. Okay, and then anything here. So that's what we need. I want you to review what we did last time on these two, and then I'll put the answers up. Alrighty, here's what I got for these two. The top equation, I got negative 1/3 x plus 3. Bottom equation, I got 5/4 x minus 2. Make sure you got those right. If you have questions, call me over. All right, what about then if we have two ordered pairs where one of them does not have a 0 in the front, meaning we have no b value? Well, that's where the new equation comes in. It's called point-slope form. Now, mathematicians are really creative, so it's using a point and the slope to write in a new equation. And the equation is y minus y1 equals m parentheses x minus x1. Now, that looks incredibly confusing. But a normal point-slope form would look something like this. Whoops, not y equals. It would be like y minus 5 equals, let's say, 1/4 parentheses x minus 2. That's a normal point-slope form. And the reason why I wrote it in this color is simple. You replace all of the red values, and the blue values are going to stay as they're given. Okay, so the equation always needs to have a y and an x in there. And in this one, y is not by itself. So let's take it slow, and I'll show you what we're going to be working with here. Here's an equation. Before we even start there, we're just going to practice where they give us the m value and we write it into the equation. Okay, the equation is written as y minus y1, which is an ordered pair, equals m parentheses x minus x1, which is the other part of the ordered pair. So here's our equation. This is our x1 and this is our y1, or y1. Okay, and here's our m value. So all we do is we take y minus the y value, which is 2, equals our m, which is 1/3, parentheses x minus the other x value, which is right there. And that is our new equation. Okay? And remember, we do this when we can't do slope-intercept form. So I want you to try to write this into the equation on your own and see what luck you have. All right, let's see how we did. So you should have gotten y plus 1, because that's a negative 1, is equal to negative 2/3 parentheses x plus 3. Now remember, because it's minus in the equation, minus a negative is the same thing as addition. So that's what you should have gotten. Now, in order to take these and to turn them back into slope-intercept form, we need to write out the equation first, okay, and then we need to solve for y, just like we've been doing. So I want to show you what that looks like. So once again, writing it into form, I'm going to go y minus 6 is equal to our m value, which is negative 2. Do that. Our m value, which is negative 2, and then I go parentheses x plus 3, because that's a negative 3 there. Now, in order to get y by itself, what we have to do is do the distributive property first. Yes, Rachel, we never get rid of it. So I get y minus 6 is equal to negative 2x plus negative 6 or minus 6. Okay, so you could also do minus 6 here. That's fine. Now, on the bottom, I have to add 6 to both sides. So I'm going to rewrite the equation down here just to make it look a little cleaner. Okay, now I need to add 6 to both sides. Okay, because that's our line. So on this side, I get y equals negative 2x plus 0. Now you could write this without the 0 here. That's just fine. And then our m value is still negative 2, which is up here. And our other ordered pair is 0, 0. That's our b value. Okay, so we should be able to go between y equals mx plus b or slope-intercept form and that y minus y1 equals m parentheses x minus x1 or point-slope form, which we're learning today. They should be interchangeable. Okay, I would like you to practice this one on your own, but I want you to put it into slope-intercept form. Okay, let's see how we did. There might be some fractions here, that's okay. So I'm going to get y plus 3 equals 1/2 parentheses x minus 4. So I'm going to do distributed property, get y plus 3 equals 1/2 x minus 2. And then I subtract 3 from both sides. You get y equals 1/2 x minus 5. Because negative 2 minus 3 more is negative 5. Right? Last one, we're going to talk about this real quick, and then I'm going to let you finish it. It'll say stuff like, can you create an equation of a line that is parallel to this line and it passes through this point? Well, we have to ask ourselves, what does parallel mean in the form of lines? If you have two lines that are parallel, once again, we've talked about this a little bit before, it means that they will travel next to each other, but they will never touch. And what that means then is their slopes have to be the same. So I know that the slope for this line is 2, and I know the slope for a line parallel, that's the symbol for parallel, is going to be the same thing as 2. So now we have a slope of 2 and an ordered pair, and I would like you once again to put this into slope-intercept form. So y equals mx plus b. Okay, see how we did? So if it's y plus 3, because that's a negative, is equal to 2 parentheses x plus 1, because that's a negative. So y plus 3 is equal to 2x plus 2, subtract 3, and I get y equals 2x minus 1. All right, this is a tricky section, so take your time on it.